And today we are going to uh, understand the topic of recursion. So let us start today's session. So today we are going to understand recursion. This recursion is one of the most important topics in data structure and algorithms for the reason that in the later data structure and algorithms we learn, we will realize that there are many tasks that can be easily done through recursion. Many implementations of the functions and many iterations. I mean, like going through a whole tree and going through every element in the tree like that thing. So there are certain things that we can do through recursion in an easy way as compared to other styles. So in this session, we need to understand what is recursion. We will also understand how recursion works. We will completely debug every program that we make. We will see step by step how what step is taking place. Then we will see iteration and recursion. We will make certain programs that will be using loops, and then we will convert those into recursion so as to explain you how this thing can be done and how recursion can implement the same thing which iteration can also do. Thereafter, we will study certain types of recursion, like we will study what is head recursion. We will also study what is tail recursion. These are very basic types, but we still need to know them. We will also see what is indirect recursion. This concept may confuse at times, but in this session we are going to cover it very well at the deepest level that we can go. And thereafter we will do certain programs that will be based on recursion. And so this is today's agenda. This is what we are going to learn today in this recursion topic. So first of all, I would like to know that how many. So I hope my screen is visible. I have also noted down the topics we are going to learn. Is it visible?
Yes, it's visible.
Okay, fine. So this is what we are going to study today. Now, I would like to know, do you know what is recursion? Any basic definition or any basic thing that you know about recursion? Please type in the comment box. Okay, Ravi Prasad says function that calls itself. Yogesh Pandey says repeated application. Okay, fine. Amit Gupta says solving same problem for smaller input. Salesh says function calling again and again is recursive function. So what I see that most of you are giving a very basic explanation of that a function that calls itself again and again is called recursion. Is it right? Those people who have an intuition about recursion, so I would like to ask them, is it right? Is it what you are trying to say? Okay. So basically you said that a function that calls itself again and again is called recursion. But my question is, how can a function be a recursion? We cannot, recursion is, what is recursion? Basically, this process done by the function, this calls itself, let me take this, calls itself again and again. This process is known as recursion. Okay, this function is not called recursion. This function is called, is there anyone who can tell me what this function will be called then? Loop? No. Yes, recursive function, right. All of you are right. The function is called recursive function. Why? Recursive function. Why? Because this is the function which is implementing recursion. And what is recursion? Recursion is the process of calling a function again and again by itself. Right? Agree? Seems apt definition for recursion and recursive function. Okay, fine. Now let us see certain examples so that we can understand what is recursion, because we CSE people do not understand things in if things just go in, just concept and theories, it becomes boring. So let's see recursion in working phase. Recursion.cpp. I hope all of you are basically aware about these, at least one programming language. I take C++ as the very base language. Okay, fine. So let us first of all make a very basic program. Let's include IO stream, right? Using namespace std, the very basic thing. And that's it. Return 0. Is there any issue in this code that I've written? I hope everyone is able to understand this. It is just, a main function that does nothing. It just returns, yes, work is done, it is successful, right? Okay, now let us make a function which implements recursion. So I would like you to please write the definition of recursive function. Could you please just write some lines? What is a recursive function so that I can implement the same definition here? I need to make the function calls itself again and again. Okay, fine. Right. Make a recursive function. Okay. So let me make, this is a function and this is calling itself. That's it. So is it a recursive function? Let me write the return statement as this one. Right, this is what the definition says, a function that is calling itself again and again. Right, let me show you how it will call itself again and again. So I hope this is visible, screen snip is visible to everyone. Okay, fine. So here we have the function. So as soon as this function is called, I have not made a call, any call from this, but when this function is called by the main function or any other function, then what will happen? The first statement in this function will be executed, right? And as soon this function is executed, it says return, but what to return? It says return it is making a function call, right? Can you see this? It is a function call. But which function is it calling? To which function this call is being made? This call is being made to this own function already, it is calling itself. It says call me again, right? Now as soon as it calls it, I'm actually continue from where I left. You can see the whiteboard visible. Is the whiteboard? Am I audible? Everyone, can you hear me? Please write in the chat box. Okay, shall I hope I'm audible now.
Yes, you're audible, Suraj. But I think you're facing some internet issues, I guess.
Yes, I don't know how it happened, but it normally does not happen. So okay,
Yeah,
so let
no
us
issue.
continue. I really apologize for the inconvenience.
Yeah,
So
yeah, it's
now is it
perfectly
visible, I
fine.
think?
Just go ahead.
Okay, fine. So this function calls itself. Now it has called itself. Now again, this function is being called. The first statement is again a function call to this function itself. So you can see it is it is like an infinite loop in which this function is being called again and again and again and again, right? Now one problem is, do you think this function will be of our use? Because this is calling itself again and again and doing nothing. Definitely not. So we need to make a function that can do something. So let us suppose our aim is to, let us suppose our aim is to print hello 5 times. Okay, so what we can do is just write hello. Fine, I give a tab. But now there is a problem with this. Can anyone tell me that what is the problem? Our task is to print hello 5 times. Exactly, Dilshad, you're right. This is still an infinite loop type of thing. It will again and again call itself and will not stop. So we need to write a condition so that it can stop. So as we want to print it 5 times, hello 5 times, so we can keep a count of this, like writing n equal to 0, and let me keep it as 1. If n equal 5, return 0, right? And here I increase the n. So now I think it is clearly visible that as soon as the value of n becomes 5, this function terminates. Otherwise, what will it do? It will just write hello and call itself again. So let us check if it is working exactly in the way we are thinking. So let us write recursion. Fine. No, it is not. Okay, okay. We have not made a call. Yes, we have declared n Arijit, but we have not made a call. I made the mistake. FUNC. Fine. Now let's try to run this. Recursion. 1, 2, 3, 4, 5. Can you guys see it has printed hello 5 times? So now we can say this is a function which is doing some work, so it is of our use. And this is a recursive function because there is a call which this function is making to itself. It is calling itself again and again. That is why it is a recursive function. So do you think there is some other way instead of writing n equal to 0 as the global variable, but still being able to use n? If I remove this from here, can I not do it like this? If I write 5 here, yes, exactly, Amit, you're right. 5 here, I give it integer n directly from here, and I increase if n is equal to 5. Okay, fine, let me. Now, okay, please confirm screen is visible. Okay, fine. So let's continue. So what it will do is, it will first of all give it 5. Here comes the 5. It will check if n equal to 5. It will return 0. So this function will not print. It will not print anything. Why? Because we are giving it 5. Here it will take 5. It will check 5. Yes, come out. Right? So we need to change the parameter. So what parameter I should give here? What parameter I should give here in this call so that I can ensure that hello is printed 5 times. Yes, please. Any idea? 0. Okay. So let's try it with 0. Now we are running this program. Let us see. Oh, it is printing again and again, infinite times. So definitely we have made some mistake. I have terminated this. Less than equal to 0. Okay. So you say we can do is n minus 1 and n is less than equal to 0. Less than equal to 0, right? Right. Arjit is right this time. He says that I did n plus plus here also. I did n plus plus here also. So what happened? 0 and there, and it became 2. So it is always a multiple of 2. It is never 5. So we need to remove this statement because we have already incremented n here. Yes, exactly, Arjit. So let us try this thing. Fine, exactly. This works fine now. It is printing hello 5 times. So there may be still certain confusions in your mind. So to remove those confusions, I will write a program and we will trace that program, right? We will trace that program, that how that program is actually working. How many times calls are being made and such thing. Yes, Amit, you have this thing in clear, but there may be some people unsure. Okay, so let us not use this function and let us write another function. Integer function 2. We say I am function 2, right? And it will say cout called. Let us take a global variable here. Integer n equal to what? N equal to, let us take 1. Called n times. Now it will get crystal clear. Now we increase n n equal to n plus 1, right? Cout hello, and return. What do we need to return here? Yes, please, this is the last statement so that we can ensure this function is a recursive function. So what do we need to return here? Any idea? Okay, fine. Function 2. Right. I repeat, we do not have any parameter here in the function 2, as you can see. So we can just skip it for this time, right? No issues, no issues. So let us try to run this thing. Instead of giving func, we will give func2. So let us see how this is working. Not, yes, fine. It is infinite number of calls. Why? Because we have not given condition here. Again, the same mistake, we have not given condition here. So what condition should we give? Okay, let us first of all look at the output. What is it saying? Called 3200 something, 3400 something. You can see it is calling itself and it is calling so 1000 number of times, and I think it is terminated. Fine, fine, fine. Right, you can see it was called 4315 times. So you can see that this function is making calls to itself. This is the proof. This is the proof that it is making calls to itself, called this number of times, right? So now let us make this function, so that it can stop. We stop it if n equal 5, return 0. Do you think this function will be now finite recursive function? Am I audible? So do you think this function will be now a finite recursive function? Okay, let us see then. Let us see if it is a finite recursive function. Yes, it called itself 4 number of times, 1, 2, 3, and 4 times only. That's it. So now this function has made call to itself 4 times only. So it is a finite recursion. It is a finite recursion that is doing some work, and this is the recursive call. We call it recursive call. This we call as base condition, right? And this is known as recursive function. Agree? I hope you people are listening. So is it clear this much? This much thing is clear? Okay, so now let's see what we have covered and what we are to cover further. So we have basically covered what is recursion and how this recursion works, right? I think this is clear to everyone now that what is recursion and how this recursion works. If there is any doubt, please feel free to ask. If there is any custom doubt which is not related to the programs that have been shown, you can then also ask. Okay, fine. So let's proceed to iteration and recursion, this third point. So let us make a new program for this. Recursion2.cpp. And here I would like to know, do you know how to write a program which can print, natural numbers from n to 1? Like if I say, I give you n is equal to 5, and I ask you, write a program that can print 5, 4, 3, 2, 1. So can you do this? Okay, so please keep on telling me how to do this thing using a loop or whatever way you find is right. Okay, I will be writing a function. IOStream, just let me write these basic things. Namespace, std, int main are very basic thing. Return 0, fine. Now, I'm writing a function int fun hyphen int n. Now tell me, what should I write in this function if I am doing fun of 5 and I want the output as 5, 4, 3, 2, 1. Okay, fine. Recursive function we will write later, but first of all we will see how we can do this using iteration, so that we will be able to see how these things are, quite a bit near about doing the same task, but in different fashion. So please tell me if you do know how to make a function that can print this using any for loop, while loop, or whatever you can implement. For loop. Okay. So what should I write in for loop? Could you please tell? Int, from where should I start? Just tell me. If I need to print this 5, 4, 3, 2, 1. Okay, 5, I greater than 0, I minus minus. Okay, okay. So I'll do this. I equal to z, I equal to 5. So we have parameter n, so we'll take n. I is greater than 0, I minus minus. And then we do C out of I. Right? We give an end line at the end. So let us run this. Okay, this is I fun. Fine. Recursion 2. So let us see what will be the output of this program. Will it print the same thing? Yes, it is doing the job. 5, 4, 3, 2, 1. Exactly the way we wanted the output. This way. Okay, now let us try to write the same thing using a recursive function, so as to get a better understanding of how it is done. So I write integer r1 means recursive function, integer n. And now what should I write here? I do not wish to use any loops, but what do I need to do is, I want to make a recursive function which can implement the same thing. Any idea? Okay, so let's do first very basic thing. We can do this base case. If n is equal to or less than 0, then return. Okay. So let's do this base case then. If n is less than equal to 0, return. Since we are returning an int, so we will return 0. Yes, C out n. I'm giving a space also. And to make this function, return function function itself. Yes, and one, so that we can ensure that every time whatever we print, it decreases, right? So let us first of all run this, and then we will see. Then we will see what we can do. Now, fine. So here we run this. Right, it is also doing the job exactly in the same way. But how is it doing? Any idea? The basic funda? Yes, go on. Just put it in small words if you can. Just acronyms and those things if you can put it. I think it is the same thing. You will be able to understand that every time we are, this function is calling itself with a reduced value of n, and as soon as, first of all n is 5, so here n goes 5. Let us track it down. 5. Then here it calls n with value 4, so it is called with value 4. Now it again prints 4. It calls itself with value 3, so it goes with value 3. It is called with value 3. It prints 3 right there, and then this calls it with 2. It is called with 2. Check, print, done. 1. It is called with 1. Check, print, and return. What? Return 0, right? Because now n minus 1 have, this was called with 1, n equal to 1, so it is not terminated. Now as soon it returns, it calls itself with a value of 0, so we enter here with 0. Now n is 0 for us, so it checks if n is less than or equal to 0, then return 0. So that's why as soon this value gets on reducing and reducing, and as soon it is called with the value 0, it returns, and so only 5 4 3 2 1 is printed. Right? Is this clear to everyone? Is this clear? Any doubts? If there is any doubt, please feel free to ask. Okay, then we can proceed further. So this much is clear to everyone that how this, I don't know, other is not responding. Yes, exactly. That is what I'm also quite a bit worried about. Are these people getting the concepts? That I'm trying to check, but it's okay. So if this is clear, please put down a yes in the comment box so that we can proceed to more complex problems. Or otherwise, please ask your doubts here. Okay, let us try tracking this function. Let us try to track this function, how it is working internally, right? At these 3 points, when the function is called, when the base condition is checked, and then when the function is called by itself again. Let us try to debug it. Fine. Fine. So here, please focus here so that you can understand very well. This is a very critical step to understand how it is working. Okay. I hope you people are focusing. Am I audible?
Yes, you're audible, Suraj. Guys, just be interactive here. Just please respond, or if you have any doubt, you can unmute also and ask. Just be interactive. There is no one here to judge you, right? Go ahead, Suraj. And if anyone has any doubt, just unmute and ask. Otherwise, drop your doubts in the comment section. Go ahead, Suraj.
Sure. So please focus here. It is very critical part of the, you know, how recursion works. If you can understand this call stack, if you can understand this thing, then I'm very sure you can easily understand how recursion is working. You also need to track down how this pointer is going from here and there, so that you can understand that how these recursive calls are made. Okay, so please focus with very high, concentration. This is the point where people, do not understand, and then they later on face problems in understanding recursion. So let's start it again. I will keep a pointer here so that you can see that this function is called. Start debugging. Yes, now just keep your eyes here on the main function. So we can see we are inside the main function, right? Agree? We are inside the main function. The pointer is pointing to this statement r function 5, but this statement is not yet executed. Whenever you see in the debug such pointer, it says this is not yet executed, but the program has come on this statement. So now let's execute this. Now you can see the function call has been made. To what function? This. We were here. Now main function called this function, and now a new record has been made for this function. You can see this function is activated now here. So we have the value of n as 5, as you can see. Hope everyone can see it very finely, that n is 5. And also keep an eye at this point, this place. Outputs will be printed here. Recursion call stacks will be maintained here, every call record. And the value of n will be shown here, updated every time. So, everything is for your convenience. So just please focus. So we step into this. So as you saw, it was here and it jumped here. That means this condition was false. N is 5. We are checking is n less than equal to 0. So it says no. So this condition turned false. So it has come to this next statement, which is printing of n. And as you can see, 5 has been printed, right? I hope this much is very clear to every one of you. How this 5 is printed, right? How this 5 is printed. Okay, so let us now see further that how this recursive call is made. Please focus, because this is the point where you might, slip if you do not pay focus. So this statement is not executed. This is not executed, but it is the statement which will be executed as soon as I press this button. Okay, so now I'm pressing this button. So you can see a new function call is made, right? You can, let me show you more clearly. First of all, main function called r function. You can see main function called r function. R function did its job by printing 5. Here you can see 5 was printed. And then what happened? Then it said the next statement is return r function n-1. That is, call yourself recursively with a value -1. So the value got updated and it got 4. So this is called with a value 4 again. But who has called it? This function has called it. You see, this function has called itself, right? I hope it is clearly visible that this function has called itself this time. And the value of n is 4 this time. So we can see this condition will again evaluate to be false, and this block will not be executed, right? Is everyone clear till this point? Okay, so let us continue. And then it will say otherwise print 5 or print 4 because the value of n is 4. So it will print 4. So let us track down. Let us track it down in VS Code itself. Now we go in. It says false. That's why you can see it jumped from here. From this point, it jumped directly here. That means the condition was false. So now you can see the output is 5 up till now. This line will be executed as soon as I press this button. So let us try to press this button. You can see 4 is printed here, right? I hope this is visible to everyone. 4 is printed. Now we again encounter that return statement. And this return statement, it is basically, what is this doing? It is again calling and again calling itself. So now please focus. Here is the main function which called R function. Then R function called itself. Now one more R function will be made above this R function. Why? Because one more call is being made recursively, right? So let us see how it happens. See, one more added, and the value of n, it was 4, 4 minus 1, 3. So you can see the value of n is 3 this time. So this has 3 inside this. You can see hover over this 3. So again it will check this thing and return 0, but no, n is 3, so it will not execute. As you can see, it will just jump from here to here. It will not go inside. It will print 3, as you can see, printed 3, and in a similar fashion it will go ahead. Now n is equal to new function call is divided by the previous function. Now again print 2. It again calls itself with a reduced value. Now n will become 1. See, n has become 1. Now this function n has 1. New function call is there, and now it will again print 1. Check here, we have 4 values printed. Now one more value will be printed, that is 1. Now printed, right? You can see it here, 1 is also printed. So now is the actual thing. Now this was the, which phase this was? This thing that is calling function, the function is calling itself again and again. This phase we call as this is basically climbing phase, or we can call it as we can call it as the initial phase in which this climbs. Yes, recursive phase, exactly. So it goes like this: main function called R function. Let me suppose R function is just R, denoted by R. Now R function calls itself. So this is again called itself. R function calls itself again. But how many times this is made? Main function called R function called R function, then again 3 times and 4 times. It is the 5th time. So 1, 2, 3, 4, 5 times. This is like climbing phase that we are going into. We are making calls on and on, right? So this is the climbing phase in which we are heading. We are creating new functions. So now we have n equal to 1 right now. You can see we are on the last statement. As soon as this statement is executed, one more call will be added. See, one more call is added. Now the count is 1, 2, 3, 4, 5, 6. N equal to 0. And we see if n is equal to 0, then do what? Return. So we encounter nothing will be printed here this time. Instead, it will be returned. See this pointer as soon as I press this button. Now you can see this has entered inside. That means it is going to execute this return 0 the very next time as I press this button. Okay, so let me come back here. Now this is 1, 2, 3, 4, 5. One more call is made, but 0 is encountered. What will happen? This will return 0. So as soon as this returns 0, what will happen? It will come back here. Now you would be might be quite confused why it will come back here, But tell me one thing. This is a main function. This is a main function. It called a function f, right? This made a call to this function. This function does all its job, right? What will happen now? The control will return back to the calling function. Am I right? The control will return back to the main function itself. Whenever we call a function from main function, the called function does its job and then returns back the control to main function. Simple. So the same thing happens here. This function will say that my job is done because r equal to 0. So it says what to do. R equal to 0, then return 0. That's it. So it says return 0. Now you can see this has ended. Now it will return its control back where? To this function now. 1, 2, 3, 4, 5, 6. You will see this will get destroyed and the count of our function will be 5. Why? Because this has ended. Let me explain you here. As soon as this ends, it returns control here. It says, okay, my task is also done because I have got the answer of this FEA. This last thing, I have got the answer of this call. It is done. Now nothing I have to do. No further statement. I'm extremely sorry. The system whiteboard crashed and the whole system crashed. So I'll be continuing. Debugging again, and we'll just quickly reach at the point where we left off, right? We'll just jump to that place quickly. We have 1, 2, 3, 4, 5, 6. Yes. So it was, yes, it was to return 1, 2, 3, 4, 5, 6. So it is returning. So I was telling about this phase. Please keep an eye over this. What happens in loop? In loop, you have, in loop there is a whiteboard. I can't start because it will again create chaos. In loop, what happens? We have, like go from 1 to 10. So loop will go 1, 1, 2, 3, 4, and so on till 10, and it will exit. That's it. But in recursion, the case is different. You can see there every recursive function, every recursive call that was made, it has every function active till now. So we need to return from every function. We need to exit every function. So we had main function R, this main function called recursive function, which called itself, which called itself, which called itself, it called itself until what? The value of n was 5, 4, 3, 2, 1, and here, right? N equal to 0. So it says n equal to 0, just brother return 0. I'm done with the task. So this is the returning phase. This was the climbing phase, or the climbing phase, and this is the returning phase. You can look at it like a mountain, where you are first of all climbing one by one like steps. You can also see it like steps, where first of all you are climbing one by one, one by one, one by one, till you reach a condition where you are complete. Then you return. Now you are returning, right? So on stairs it will be quite tough to show you how you will learn like that. So that is it. Now you will return from here. This. So this is crossed. Now it will say, okay, my task is also done, because no statement is there after this statement, right? As soon as finished, what is the statement in this function? Nothing. So it will say, I am also done. I have nothing else to do. So it returns to the previous calling function. It also says, I have nothing to do now. I'm also done. Return. And these are crossed. These are crossed. They do not live in the memory now. They go out of scope. Now control comes here. It says, okay, I also do not have any statement after this statement. So I'm also done. It returns the control here and goes out of scope. It says I'm also done because it is the same function. So every function is done at the same time. This gets cancelled. This says I'm also done. So it returns to main, and this also gets cancelled. Now the only function that is remaining is the main function. Made this call, and this call will return control to me. What does it say? I made this call, and whatever it does, I do not know what all this thing it does. I do not care about this. I just made one call, and now this last call has returned control back to me. Right? Now this function has completely executed. Now I will execute the very next statement, which is return 0. And we know when return 0 is encountered in the main function, the program ends. So let's see this thing in action. Agree, everyone? The thing that I've explained is clear. Is it the same thing which happens? Is it the same thing which we have learned up till now? Okay, so let's please focus here. Now, since this call is completed, this is return 0, so it comes here. So it will go out scope now. See, one call is terminated from here. Now it will say, okay, Mike, this call is finished. What do I need to do next? It will say nothing. I also need to return. So it comes here, next call, next task, but there is nothing to do. So it just exits. Exited. You can see one more call destroyed. Now it says, okay, this thing is done. I have already completed this call. Now what to do? Let's go to the next statement, but there is nothing in the next statement. So it will say, okay, let's go out of scope. So that is also destroyed. It has also done this work and has control has returned here. It says, okay, let's now execute next statement, but there is nothing. So it also exits. One more call destroyed. This will also do the same thing. This also destroyed. This will also do the same thing. And this is the function which main function had called. This will also get destroyed. Now main function says, okay, I have done this task. This call has returned control back to me. Now the next thing that I need to do is return 0. Let's do this. So it returns 0 and the program ends. You see, the program ends and the debugger also just closed. And what was the output of this program? The output of this program, as you can see, was somewhere, you can find it, where it went. I'm quite sure it could have written its answer somewhere over here. But you have seen its answer is 54321, right? Is it clear to everyone how this function, made calls to itself, how it was working in the climbing phase, how it, came back in the returning phase? Recursion has two phases. Recursion has two phases, that is a climbing phase and a, returning phase. I'm extremely sorry. If I could run the whiteboard, I could have explained you a little better, but it will crash the system again. So I think climbing phase is very, very clear. When function is calling itself again and again, that is the climbing phase. And what is the returning phase? When the function is done with the calls, then it will return. So that is the returning phase. Agree? And at the end of the returning phase, the program ends. Right? So if there is any doubt, please look at this program very carefully. If there is any doubt to any one of you, please ask. Look at this program, thoroughly, go through it, and if there is any single doubt of any type of doubt, if it is an easy doubt or a typical doubt, or you are not able to understand something, any type of doubt, please ask. Every type of doubts are most welcome, because if we do not ask our doubts, so that becomes hindrances later on. Sure, I'm pasting it here. You can also run it. If there is any problem even on your system, you can tell me. I shall be able to figure it out and tell you. I will also paste the first code, and I will also, push these codes to my repository, and I will provide you a link of that so that you can download these codes anytime. And if there is any problem, you can generate an issue there or directly contact me through mail or any other means that you have. I think I've pasted it. Please go through both of these codes thoroughly, and if there is any problem or any doubt, please ask. I hope everyone is clear in this. Is there any doubt? Please respond. Am I audible?
Yes, Suraj, you are audible clearly.
Okay, okay. To proceed with the further topics, we will need to understand the things that I have just explained very well. Because if it happens that understand any of the concept and we proceed further, you might find certain difficulties in that. Because as soon we start diving in recursion more and more, it becomes a little bit more and more complex. So you need to trace it down very well. So if there is any doubt, please ask. I think everyone is clear, then we shall proceed further. Is it so? Please do respond. Okay, then let's go to the next thing. We had kept what is recursion, that is done, how recursion works, that is done, iteration to recursion, and the relation, how both of these can do the same task, that is also done. Now we have head and tail recursion, and then we will go for certain examples, right, on the recursion. So let us then see what is head and tail recursion. For that we will make a new file, head and tail.cpp. Fine. Let us close all those files. Let us create that very simple program. Hash include iostream. Okay, so let us now understand what is head and tail recursion. So I think everyone is up. Yes, please put messages in chat box. Okay, so let's start with head and tail recursion. So there is not much difference in what is head and tail recursion. It is just the difference of how we are doing our task. There are two ways. One way, now I will explain you better this way. One way is that you can do work like this, do work recursively call, and the other is recursively call and do work. These two different things only, in which one is you make a recursive call later on, and one is in which you first make a recursive call then do your work. So this is when you do your work in climbing phase, that is what we have learned up till now, and the other one is when you do your work in the returning phase. So this one is called tail recursion. Okay, recursion. This is tail recursion, and this is head recursion. So this is what we have up till now learned. Which one? We have learned tail recursion. How can I say we have learned tail recursion? Well, let's have a look in this. Not this. We have always made a call at the last. We have first done our work, that is printing, then we have made the call. So this is what we have already done. Now let's take an example of head recursion. How does head recursion work? If I write the same program, I just copy paste the same program, this R function. Let me show you how I'll do this. This is very easy concept. I'm pasting it 2 times. So let me write here head, not fun, head rec, and here tail rec. Fine. Okay, then I also need to change this tail rec, and this is head rec. Fine. Now, what changes do I need to do in this head recursion so that it is head recursion? So the basic definition that we have is, in head recursion we first call, then we do the work. So let's do this thing. We will do the work later on. We will call first. But then we also need to adjust our base condition accordingly. So we will change this and we will do this greater than 0. Why greater than 0? If n is greater than 0, keep on calling yourself. But when n is not greater than 0, that is the same condition. When n is less than or equal to 0, that condition, then we will just print out. Right? So what we are doing is we have just changed the condition. We have taken this to upside and we have done our work at late side. Right? That is the only difference we have made. So now let's try to run this. What will be the output of both of these programs? Tail recursion, I give 5 here, and out end line. Add recursion, I give 5 here again. Out end line. Fine. Now let's try to compile this. Says fine. Says it did not return anything. So RETRN return 0. What we have done is we have, instead of this, we have removed this thing. We have put it there, and put that down. We do not even need this. Okay, so let's continue. What we have done is only we have swapped the places. Recursive call and then do work, recursive call, do work. And in tail recursion, do work and recursively call then. So do work and recursively call then. Okay, so let us try to compile this. So it is, what's the name? It is head and tail recursion. It did not print anything. Why? It's quite odd. Let me check. Build finished. Right. So you can see 5, 4, 3, 2, 1. Tail recursion has done its work, but it did not do its work. Why? Why? It has just printed 0. Any idea why it is not printing what we are trying to print? Let me tell you. why it is not doing that thing. The thing is,
Suraj,
yes,
uh, your message box is stopped. Everyone is responding, but in your chat not visible.
okay. I just checked it. Is my screen visible and am I audible? Fine.
Yes, my friend.
Okay. So I'm extremely sorry for that. I did not pay attention that it was some scroll bar thing. Okay, so now we can see that our previous function, that is tail recursion, is working fine, but our head recursion is not working fine. Why? So what I'll do is, this is tail recursion 5, head recursion 5. Let us comment it out and let us see why this is not working. Head and tail, and it only prints 0. We are given 5, it goes, calls itself again and again. Let us try to trace it, right? In such problems, when we do not know how the function is misbehaving, what we can do is we can trace the function, right? We can trace the function. Once, let me do this thing also. We will trace the function like the previous way, and you will see, okay, you will see why it is happening. What if I just remove this thing? These are certain things that you can do when you face such issues, like you have written a program but it is not, you know doing the job. You write here void because now you are not returning anything. You have removed the return statement because when return is encountered, the function exits. Now let's try it. Fine, it is doing. So now you see, certain times you may need to you know check your program if it is doing something, like return statement is given. So this might happen in recursive programs many times, because you can see there it was working fine, but here it is not working. So we had to change it, right? But there is one problem. This 0 is coming, but we do not want it. We just want the natural numbers. So we can do this. Fine. It is printing 1, 2, 3, 4, 5. Now you would be wondering why it is printing 1, 2, 3, 4, 5. The same function I have copied and pasted down, just change the name. I have again pasted the same function, change the return type, and the same function is there. I just swapped the statements to make it head recursion, and the whole output is changed. Right, you can see the output of previous tail recursion also. Let me show you. See, see, the tail recursion is printing 5, 4, 3, 2, 1. Looks like a tail, right? It is decreasing. And this is a head recursion starting from 1 to 5. So this is head recursion. But you would be saying that I have not done, you can see I have not added any more code. I have just swapped the statements as per the logic that I gave here, right? And the complete program output changed. Such type of question you will definitely face in examinations, and I'm sure you might also have faced in previous, if you are a second year student, you might have faced these in semester 1 and 2. So why it is doing so? Let us quickly try to check it. We will debug it, how this is working. Fine. So please pay attention when head recursion is called, right? I'm going full screen, but I will like this short my screen at many times. So please, if you have any doubt, you can put in message box. But if I have not seen it, you may unmute and directly ask your doubt. No issues. So let's debug it, how it is behaving in this way. Let us check. So let us open the call stack. Here we are in the main function. This is not yet called, but it will be called now. So it is called. It checks n is 5. I hope everyone can see n is 5. Right? And we are in the head recursion function. Let me do something to this terminal. If I hope this setup is fine. Okay, so let us proceed further. We go further. It says n is greater than 1. Yes, of course, n is 5. It is definitely greater than 1. Then call yourself again. It says, okay, fine. It has again come. You can say next record created. That is, it has called itself. So one more record created. It says, now what to do? It says, check if n is greater than 1. It says n is 4. True. Then call yourself again. This way it will go on calling itself again. Now it this time 3. For 4 also, for 2 also. Now n is equal to 1. Is 1 greater than 1? It will say definitely not. 1 is equal to 1, but it is not greater than 1. So this condition turns false. So this will not be executed this time. Then what will happen? Next statement will be executed. And the next statement is cout. So you can see we have, main function called head called again, head again. So climbing phase is completed. Now we are in the returning phase. And up till now, this has printed nothing. This is printed by tail recursion. But head recursion has not printed anything yet, as you can see. So it will print now in the returning phase. That's why we call it, head recursion. It goes on heading, but does nothing. And then comes back. In the returning phase, it prints everything. Now see, it printed 1. Why? Because n is equal to 1. Now this function will get destroyed because there is no more thing to execute. And the control will come back to this. Now n was 2. Why n was 2? Because see, n was 2 here. That is why this function had made a call with 1. And that's why one more call was over there. And 1 was printed. Right? So we are going in back order. Every decrement is now destroyed. Right? Print 2, come out. One more call destroyed. Now this. It will say what is n here? N is 3. Print 3, come out. Print 4, come out. Print 5, it says okay, my task done. Main function, return control. So the control has come back to main function. Main function will see next statement is give a new line. It gives. It says okay, return 0. So it has nothing to do. Finished. You can see 1, 2, 3, 4, 5. So that is how 1, 2, 3, 4, 5 is printed. Now do you have any doubt in this? I will further explain you with the help of this. So what happened here, let me explain you here. This was main function. This called recursively head. This called head. This called head. This called again head. 1, 2, 3, 4. 4 head. This is 5th head. This is 6th head. But here we have value equal to 0. It is not considered. It returns. So it just returns. It was how many calls we made. We have checked n is greater than 1. So we have this time we made only 5 calls. Right? We did not make 6 calls. We only made 5 calls. So as soon we came here, it was this said, I do not know anything. Pardon for the interruption. I'll continue from where we left off. It was, I call it VS Code. Yes. I'm going to share my screen. Please confirm if it is visible now. I hope this is visible.
Yes, it's visible, Suraj.
Okay, fine. So it is it. This tail recursion, what does this tail recursion does is, in the calling phase, it does its job. Do job, then call. Do job, then call. That's why we called it for 5. It printed 5 and return. It is like, call yourself again with a reduced value. So as soon as it came 4, it said, okay, print 4, then make recursive call. Print 3, then call. Print 2, print 1. That's why this pattern was printed. This 5, 4, 3, 2, 1 pattern was printed. But in this, what it does is it says, if n is equal to 1, call yourself with a reduced value of n every time. So we gave it 5. It said, okay, fine, 5 is greater. Call yourself with 4. It said, okay, 4, call yourself with 3. And one above another stack was made. Let me check it. Fine. So it was main function. Now above it, this function was called with 5. It said, okay, n is greater than 1. Do me a favor. 4. Call yourself with a reduced value. So 4. Then it said, okay, fine. Call yourself with a reduced value 3. It said, still it is greater than 1. When 3 was here, it said 3 is greater than 1. Yes. So it called itself with 2. It called itself with 1. As soon as it came on 1, it said 1 is greater than 1. It said, no, it is not greater than 1. Then what to do? This is false condition. Do not execute. Come down on this statement. So it said, okay, print n. So what is n here? Can you tell me what is n here in this function? In the above function, in the above-most function, what is the value of n? I hope you can see that since n has reduced from 5 to 4 to 3 to 2 to 1, so the value of n is 1 this time. So 1 is printed. 1 printed. Now this function goes out of scope. Because after 1 there is no statement. So it goes out of scope. Then 2 is printed. So it prints 2. Goes out of scope. Prints 3. 3 is printed, goes out of scope. 4 is printed, goes out of scope. Now this last function, this 5, it prints 5. And since nothing is there after this, goes out of scope. Then call comes, the control comes back to main function. And main function says return 0. Program ends. That's how 1, 2, 3, 4, 5 was printed. I hope this is clear. Yes, Kiran, right. First 1, 2, 3, 4, 5 is printed, and then this exits. But in tail recursion, it prints 5, 4, 3, 2, 1. Exactly. Now tell me, what if I combine both of these? Can you tell me what will be printed if I say void combined int n cout n and if n is greater than 0, n is greater than 1, then combine, call combined. Oh goodness. Yes, so combined with n minus 1. Fine. Otherwise, cout n. I'm telling you, it will look little bit complex, but if you can apply a very, there is nothing complex in this. It is a very common thing. It is going to do a very, very easy thing if you can decode this. Since you have studied recursion to this point, I'm very sure you can decode this. So let's call combined with a value 5. But you need to be very focused how this is doing this job. So our area of interest now is only this code combined. As soon as we enter into this function, it prints, it checks, it calls itself again, prints, calls itself, prints, calls itself. So you can see this behavior is like which function? If I only see this print, check, print, return. It is basically, do work, recursively call. It is tail recursion. Am I right? Yes. So basically it is tail recursion. Why? Because it is like do job and call, right? Do job and call, do job, call. But if I see the lower section, this, what does this definition says? It says call, then do job. And it is the definition of call, then do job. This is the definition of head recursion. So I have combined both of these recursion. So now you will see the output where both of, the output will be the combination of the outputs of both head and tail recursion. What output these programs were giving, that output will be given by this single program in one go. Let us see how. Okay. Let me write. It is head and tail recursion. Oh goodness. Fine. Head and tail. Right. You can see what it did. 5, 4, 3, 2, 1. Now can you tell me what was the which function had given us 5, 4, 3, 2, 1 as the output? Which function of these two had given us this 5, 4, 3, 2, 1 as the output? Yes, please look at this code very well and answer which function had given us output only this much, 5, 4, 3, 2, 1. Are you sure, Kiran, it was head recursion? We have passed 5 here, so we want to print 5, then call recursively. So which function gave the output 5, 4, 3, 2, 1? We passed 5 n equal to 5, and we said print 5, then 4, then 3, then 2, then 1. So how it will happen? It will happen when we print first, then make a call, reduced call, print then make a reduced call. So this function is doing this thing. Print first, then make a reduced call, print first, then make a reduced call, right? So this first output is of tail recursion. I know that this sometime may confuse you because this tail recursion and head recursion words are quite a bit confusing with the output if we match it. No issues. So this is the output of tail recursion, this half output, and this one output is of head recursion. First call, then print. So you can see this thing has been done in calling phase. In the calling phase, this is printed, and this portion is printed in the returning phase. I hope you are clear with this thing, right? So that is how we have combined, and this function is working. Now we are just left with only one more thing, and that is certain programs on recursion. So let us see. I think you people know how to write a factorial program. Yes, do you know how to write a program for a factorial? Okay, fine then. So let's try to write hash include iOS stream using namespace std int main return 0. Fine. Now let's write a program for factorial. Int factorial integer number. And what do we do? Like if I know that factorial of 5, if we want, then we do 5 into 4 into 3 into 2 into 1, right? Oh, goodness. 5 into 4 into 3 into 2 into 1, right? So this is what we do. So we need to write a loop. Just a second. Okay, so let's continue. So we know we will run a for loop from where? From 5 to I is greater than equal to 1, I minus minus, right? Very clear? We are starting from 5, or we are going to 1. So we need to calculate factorial. So let's keep an integer named fact equal to 1. And what we need to do is we want a multiplication of all these numbers. So since this for loop will give us all numbers, so we will do factorial into equal to I. This is shorthand, but let me write the full hand then. Fine. And here we return factorial. And here we do see out what? Factorial of 5. Fine. Let us try to run this. Not head and tail. This is what? Factorial. This is factorial. Fine. Right. So factorial of 5 is 120. So it is working right. Now let's write a recursive function for this. Yes, right, Kiran, exactly. Factorial is equal to factorial into I. So let's write a recursive function for this. Integer recursive factorial integer n, and let us, if n is greater than n is equal 1, because we are running till 1, so our condition we have is I is greater than equal to 1. So we are ensuring that we do not go below 1. So as soon we reach 1, we will return 1. Otherwise, what we will do? We will return n into r factorial of n minus 1. Now you will be wondering what I'm doing here. So let me explain you in a quick manner. Is 5 factorial. So can I write 5 factorial is equal to 5 into factorial of 4? Right? Now how I will write 4 factorial? It will be 4 into factorial 3, right? Now I need to define what is factorial 3. It is 3 into factorial of 2. Now what is factorial of 2? It is 2 into factorial of 1. And what is factorial 1? We know it. As soon as n equal to 1, return 1. So what is the result of this? This is equal to 2 into 1 equal to 2. And this 2 will be returned here. This factorial 2 will be having value 2. So what will be the output of this? 3 into 2, that is 6. Now factorial 3 value we have what? 6. So we return here. This becomes 4 into 6. So it is 24. Now we return again. Now we know factorial 4 is 24. So do what? Do 5 into 24, which is equal to 120. That's it. And return 120 where? Return it to the calling function. Which is the calling function? Definitely we are going to have main function as the calling function. Good afternoon, Javeer. Nice to have you here. R factorial of 5. And we again give an end line. Fine. Oh, goodness. Now see. Fine. So it is also printing the same thing. It gave the iterative version, that is factorial. It gave us 5 factorial as 120, right? Now the recursive function, that is R factorial, it is also giving us the same output 120. And you can see that this iterative version is taking so much of code lines, but recursive is taking so less code lines. So you can see that through recursion we can implement big functions very easily in a very short code, right? And it will still be working exactly like the original function. Do you see? Just 3 lines of code, and there we need to write a for loop, then this, declare a variable, and so on things, right? So I think this is also clear. So now I would paste this code to you also, so that you can try to run it. And one program that you all can try to make is a program that will give the sum of n natural numbers. You need to write both iterative version and recursive version. Fine. So this is the thing. This is the question that you can try to do is a program that will give you the sum of n natural numbers, and you need to write both iterative version as well as recursive version. You can try this program. It is exactly like this factorial program. You just need to make very small changes, right? Like here you are doing multiplication. So what do we do? Like we are given 5. So we'll do plus 4 plus 3 plus 2 plus 1, right? That's it. So it is very basic, just a small change you will do here, and you can make this program. I hope this is clear. If there is any doubt, please feel free to ask your doubts. I had pasted this, but I don't think it has come.
Guys, if you have any doubt, please ask, or we'll wrap up the session now.
Thank you, Aman. I hope you really got something from this session to learn. And every one of you, if there is any doubt, please, you may ask right now. But even if after the meeting you face any doubt, you may text me through my email address, or either you can directly contact me through the GFG groups in which you are.
Guys, if you have any further doubts or any doubts regarding the question that Suraj gave you, you can ask. Feel free to ask in the Telegram group that we have created for you. So ask there, and so when Suraj clears your doubts, everyone's doubts will be cleared at once. And I guess Suraj, that is all. Nothing is left now.
Yes, yes. Almost
Okay.
everything wrapped up.
Okay. So we'll wrap up the session now, guys. You can leave now if you don't have any doubts.
Thank you, everyone, and thank you for coming in this session. Thank you for your support.